Hi everyone, I'm Alexander, and this is the Boosted Brake Remote, or more specifically, my V1 prototype of the Boosted Brake Remote. This is something I've been working on for the past few months, pretty much ever since my last video where I demonstrated I could get a Bluetooth dev kit to control a Mini X. In fact, this Mini X that's at the bottom here. But now I want to do it with a PCB form factor that fits in a remote instead of a dev kit. So that's what I've been working on here. Yeah, so this video tends to be a showcase of the PCB and the features I have working right now. So let's get a closer look at what's going on here. As far as the design, I'm using the Blue Energy 2 Bluetooth application module. Pretty straightforward, comes from ST Microelectronics. Yeah, that's all I need to say about that. As far as user input, we of course have a power button and a trigger button, right angle button up there. And I am using a 3-axis magnetometer at the top there. What's nice about using 3-axis instead of the single axis that the original Boosted Remote used is that we can get a better understanding of the magnetic field. More specifically, for example, you can actually understand like the total magnetic field at the sensor. And this is useful in the very, very rare case where, let's say, you take a tumble and your remote, cracks apart and your thumb wheel goes flying off. You would definitely not want the remote to tell the board to go max throttle one way or the other. That, of course, would be pretty dangerous. So we can understand, hey, are the magnets even close by to the sensor? And if not, we can say, something must be wrong. Let's neutralize that throttle. So yeah, so that's what's going on there. Let's talk about some user output features. We, of course, have a piezo buzzer, alarm buzzer. Pretty necessary to get the user's attention. Let's get that in focus. There we go. So I have that, as well as some LEDs. Of course, Boosted has the iconic 5 state of charge LEDs. I will be doing the same. In fact, I'm using almost the same exact LED driver that Boosted was using. So, of course, 5 state of charge LEDs, a Bluetooth on-off LED, and a power LED that's green and red. As far as power, I actually plan to be compatible with Adafruit batteries. I think the 420 milliamp version will be perfect for fitting inside the remote chassis. Yeah, and it's nice using the Adafruit ones is that they're available and they have protection IC already on them. It's kind of an added layer of safety in case things do go wrong. Yeah, of course, when you have a battery, you also have to be able to charge it. So it's not populated on this board, but I plan to use a very basic, micro LiPo charger, the same one that Adafruit uses on most of their products on this board as well. Finally, we can talk about something special. I have a USB to UART bridge on this board as well. And that's nice for debugging. You get a serial port, you can talk to the board and the board can talk to you. But a unique feature of this Blue Energy 2 is that it actually comes with a bootloader baked in. And you can't brick it because it's in the ROM. And you talk to it over UART, which you can then bridge to USB with a chip that I have on here. So what's nice about that is that opens the door for firmware upgrades in the field. So let's say you have this remote in your hands and suddenly there's a firmware release that is necessary for this board that we can basically distribute the hex file and the instructions on how to load it on here, and anyone with a laptop and a USB-C cable can bootload this board, get that new firmware, and keep on going with their riding. So yeah, this is struggling to stay in focus, but yeah, so that's what's going on here. So as far as some features on the table that I'm not yet planning to put in, I think the one thing that we've been hearing, of course, a lot of what we've heard is, hey, let's get USB-C on this board. That's been done. But we also talk about getting, like, understanding the state of charge of the remote battery, which would go where my thumb is. So I have some features associated with that. So long story short, I'm using a ideal diode O-ring IC, and we have visibility on the power supply, the voltage of the powering power supply. And so the idea is that when you plug in USB-C, you generally want to get power not through the battery because you want to charge the battery. You want to get power through the USB-C or USB interface, say from your laptop. And so we'll have only visibility on the powering IC, power supply. So long story short, if you're not charging this board, we can determine the voltage of the battery and then convert that into a state of charge of the battery on the remote. So that's an improvement over the boosted remote. Boosted remote only gave you basically two states of either good or bad. So this one will give you definitely a little bit more, but we unfortunately won't be able to tell you the state of charge state of charge of the remote battery while you are charging the remote battery. But I think for the most part, once you're charging, you just care if it's done or not, which of course we can tell you that. So that's what's going on here. Let's kind of show this in action, shall we? So I'm gonna move over to my fully assembled setup. I'm actually gonna plug him in so we can get going, and we can start showing that it actually works with a boosted board. I will say from the get-go, all the features that I introduced in my last video with bonding and pairing and all that, that is still the case here. But for brevity, I won't be going over all of that. Let's just show that it works. So I'm gonna get an angle where I can show you the wheel, and then actually let me turn on this Mini X. There we go, he's on. We actually are connected. So there's some debug features that I have implemented on the serial port that I'm talking with my laptop to the board. So for example, I can basically pretend that the trigger's pressed with the key press on my laptop. There you go. You can hear the motors are starting to do stuff. But I think the more important thing is, hey, can we use the thumb wheel? And the answer should be yes. I'm going to be very slight. So it's pretty aggressive, partly because... There you go. Yeah, I'm being very slight, mainly because when you're not riding, there's very little resistance, so the motors really want to go. But you can tell that we can control the board. So I can go in reverse. That's reverse. And we can go forward. So that does work. I'm gonna release the throttle so that we don't have so much noise from the motors. I can also say that I can change the speed modes, which is pretty important. I'm also going to simulate that through the serial port, simply because I can't press the button as the remote PCB is sitting there, but I can at least show you. If you heard that, you heard that the beeper, that's what it sounds like on the V1. You might have noticed it's pretty soft, not very loud. That's something I have to remedy with the V2 prototype. But it does work, and we can change speed modes. In fact, we can go up and down. So I went down a speed mode there. Yeah, unfortunately, without riding the board, it'd be pretty difficult to show you that actually had an effect on the board. So instead, what I can show you is sending the command to turn everything off. So let's do that here. So when I do this, send this command over, you should see the boosted board, the Mini X here turns off. So I'm going to do that right now. There you go. So that's basically simulating that you powered off the remote while the throttle was pulled back in reverse. Yeah, okay. So I suppose now I can also show you the LEDs a little bit. Alright guys, I've done a quick cut here to get the V1 prototype PCB out of the shell. And the reason for that is I want to demonstrate the LEDs on the front side. The LEDs are the primary way in which a boosted remote communicates with the user. So I wanted to show you how it looks on my board here. I'm going to actually unplug and then re-plug back in to show you an example of a power-up animation. Here I'm simulating that the battery is at 60%, and when I say battery here, I'm talking about the remote's battery. You'll know that on an original boosted remote, there's only two states, right? It was green or red for good or bad. And one of the things that we commonly heard with interest on this remote is, hey, let's have some insight on the remote battery state of charge. So on startup, I plan to kind of show you where it's at. And through the serial port, let me get that up and running. I can tell the remote to basically animate anything I want it to do. So for example, let's say you're at full charge, it'll look something like this. So it goes up to 5 and then targets 5, shows 5, and then comes back down. That's like 100%. I can show the same thing doing maybe 20%. So it looks something like that. Maybe 10% where it'll blink. You'll notice that this blinking animation is kind of a ramping style. I think the original boosted remote just did a step. It was a little abrupt on or off. I think this looks nicer, but I suppose that is subject to change. I can also show you kind of a fast blink, where like in the case where battery is very low, we might show that. Yeah, so that's what it looks like. I can also show you some other state of charge animations, such as the speed mode. When you change speed modes, you'd get an animation sort of like this. You can see that was like speed mode 3, where it climbs 3 times. I can also show you the same thing, but for speed mode 5, it'll climb faster and it'll do 5 times, do the climb 5 times. Similarly, when you go to the slow speed mode 1, it'll climb very slowly and only once. So that is also on the board. I also have a power off animation. I call this the fall. So it looks something like that. And similarly, there's a power up animation like that. Those are all in my firmware, ready to go. For the connection LED, I can show you what it looks like to get into pairing mode. And you'll notice that the buzzer beeped 5 times to also indicate that. So it'll breathe when you're in pairing mode. I think it's pretty smooth there. We can also exit that real quick just to, yeah, exit that. I also have the blue LED do the kind of half blink for the speed mode you're at. To show that, I think it'll be easier if I just turn on this guy. There we go. So you'll notice that we're at speed mode 3, and it'll blink 3 times every couple seconds to indicate that. And yeah, let's maybe go down to speed mode. So that was speed mode 2. Go up, back up. And let's go down one more time. Maybe I'll show that it's actually blinking twice now instead of 3 times when it's at 2. There you go. Pretty cool stuff, right? Yeah. All right, so I'm gonna turn off the board now. So we don't have to worry about anything. You'll notice that blue LED is now gone away because, board's not on anymore. We're disconnected. Yeah, so this is the state of the V1 prototype. We have definitely a lot of progress made with this design. Pretty happy with how it works so far, but it is definitely not finalized yet, unfortunately. So There's a few things I need to work on. I think the first thing to mention is sort of positioning of the button and the trigger and the USB-C port. The original remote, of course, had mini B, and the way the USB-C is positioned on this prototype, it doesn't fit. I think I need to make it taller, so I'm going to find a taller USB-C port, and hopefully that remedies that. There are some other things that I want to work on. I think I want to change the buck boost regulator to something else that's easier to hand solder. That's another thing. I also want to work on the quiescent power draw of this board. As it stands right now, it's borderline unacceptable. I have to figure out why it's not acting like I wanted it to. But the long story short is, I think part of why this guy is battery, you rarely have to charge this thing, maybe once every couple of months or something like that, depending, of course, on how much you ride. I think that is mostly due to that they have excellent or practically no current draw, no power draw when the board, or I should say the remote PCB is not, doing anything. It's powered off just like it is, in my hand right now. And that's something I want to replicate on this guy. And right now, V1 is definitely not up to snuff. So I'm going to figure out why and remedy that. Yeah, so those are some things. So again, there's some things that need to be worked on. But long story short, if you guys are interested in this, basically the hobbyist reverse engineered recreation of the boosted remote, I'll have some links in the description of this video that you can use to help us gauge interest. And yeah, so this is pretty much my first independent, for the most part, almost independent hardware design board, whatever you want to call it. And yeah, it's been a lot of fun working on this. Definitely could not have made this without plentiful of help that I've gotten from coworkers, as well as XR General Hospital and David. So yeah, so I want to thank them, and I want to thank you guys for having interest in this and watching this video. And yeah, I think that covers everything I wanted to say. So yeah, again, thank you, and have a good rest of your day.